Let's go ahead and combine a whole lot of things we've learned this unit into one problem to find both the maximum height of a ball that we throw through the air as well as the amount of time that ball is in the air. So we're going to combine a few different things with this problem. First thing first, we need to make sure that we're using this as our vertical motion model. So we've talked about that in class. The -16 comes from physics, so if you're not sure where that's coming from, don't worry about it. That's a physics question. And physics people, you may be used to using -9.8. That's because we're simply using different units right now. You're probably used to using meters. Our book is using feet as our unit. So here's our model. Let's go ahead and take this data, write our model, and then answer these questions using both the quadratic formula and some old things about graphing that we haven't talked about in a while. So in our model, the h over here represents the final height of the ball. In this case, we're going to catch it 3 feet off the ground. So that final height's going to be 3. -16 is there, as I said, just part of physics. T is the time the ball's in the air. So that's our variable, so t squared. In our equation, v sub o represents the initial vertical velocity of the ball, so how fast we throw it initially. And I can see from the problem that that's initially thrown at a speed of 40 feet per second. And then the h sub o at the end here represents our starting height. It looks like we threw the ball in the air with an initial height of 4 feet. So there's my equation set up using the vertical motion model. The first question they asked me is how long is the ball in the air for? To answer that question, that's where I'm going to be using the quadratic formula because I want to solve for t. And so using the quadratic formula, I'm going to need to be equal to 0. So subtracting 3 from both sides, I get -16t squared plus 40t plus 1, because I've subtracted that 3, is now equal to 0. So using the quadratic formula, that will answer the question, how long is the ball in the air? So I'm going to skip the work for doing that. If you want to pause the video and do the quadratic formula, go for it. You may have a program on your calculator that will do that for you as well. Because we're working with a story problem, let's go ahead and round our answers, or answer, to a couple decimal places. So using the program, I've gone ahead and done that ahead of time. I came up with an answer, a time of approximately 2.525 seconds. Again, because I'm using doing a story problem, I'm okay getting a rounded answer in this case. Now, there were 2 answers I got. The other answer, though, happened to be negative, which would not make sense in this question, so I ignored that negative time. Now, the next question they asked me is, what time is the ball at its maximum height? Well, it's not necessarily half of 2.5, the time the ball's in the air for, because I didn't throw it from the same height that I caught it at. So to answer this question, remember, maximum height just refers to the vertex. So going back to the beginning of this unit, I want to go back and find the vertex of this parabola. I can do that by hand, or what I'm going to prefer to do, because I want to see the graph of this, I'm going to make a sketch of this graph. So here's what my graph will look like. I mean, it's going to be some kind of upside down parabola. What I want to do, though, is obviously do a better job than this. So let's switch over to the calculator and take a look at how we can, or review how to find the vertex. So I can answer the question, not only when is the ball at its maximum height, but what is the ball's maximum height. So this is not quadratic formula. Quadratic formula tells you how long the ball's in the air for. To find maximum height, we're still finding vertex. So let's switch over to the calculator.